Hello and welcome to the Theory of Computation lectures. In this class, we'll talk about Non-Deterministic Finite Automata or NFA. Now let's start by asking ourselves a quiz question. What would be the audio output of your TV if you press the mute button? So in your remote control, if you press the mute button, what would be the audio output of your television? The choices are A, audio on, B, audio off, C, both A and B, and D, none of the above. So if you have guessed the answer as B, then you are absolutely right, the audio will be off. But let me ask you a question. Is there a choice for your TV to say that, no, today I am not in a mood of, switching off my audio, I will keep the audio on. Is there a choice like that? No, right? So when you press the mute button and the audio would be off, you know for sure, right? So let's ask a different question. So what would be the noise level of your class if your teacher shouts silence? So suppose there is a noisy class and students are talking to each other and the teacher gets very angry and shouts silence. What would be the noise level of the class after that? The choices are A, noise on, B, noise off, C, both A and B, and D, none of the above. Now, answer to this question depends on many things, right? What is the nature of the students in the class? Are they very naughty or are they obedient? What is the personality of the teacher? Are the students respectful of the teacher, or they think that okay, they can get away if they still make some noise? It depends on many factors. So is this the day before the vacation? Then the students and the teachers are naturally in a different kind of mood, and there are many things that affect the answer, and we cannot really say what would happen if the teacher shouts silence, right? The noise may be off, it might be on, or some students may be talking while others will keep silent. We don't know. So this behavior is called non-deterministic, where we cannot predict what will happen even if a command is given. In the previous case, when the mute button was pressed, we could predict what would happen. That's a deterministic behavior. But in this case, the behavior is non-deterministic. So essentially all machines are deterministic, whereas human beings are non-deterministic. But conceptually, we can also think of non-deterministic machines. Let's try to understand by seeing a couple of examples. So in case of a deterministic machine, which operates over an input alphabet of 0 and 1, you can see if I ask you for this machine, if I give you input 0, what would be the next state? Can you tell me? The answer is yes. If the machine is in initial state A and the input is 0, the next state would be B. There is no choice for the machine to go to any other state but B if the input is 0. So it is a deterministic behavior. But now look at this machine. If I ask you, if the machine is in initial state A and if I give you input 0, what will be the next state? Can you give me the answer for sure? You see, the machine can either go to state B or it can go to state C on input 0 from A. So we cannot tell for sure or for certain which will be the next state if the current state is A and the input is 0. So the behavior is non-deterministic. Now once again, looking at the deterministic machine, if I had asked you, if the current state is A and the input is 1, can you tell me which state will be the next state? You could have said yes, the next state would be C. Now look at this machine. In this machine, if I ask you if the current state is A and the input is 1, what would be the next state? Can you tell me for sure? Okay, in state A, there is no transition for input 1. So we cannot say what would be the next state if the input is 1 on state A. Again, this is a non-deterministic behavior. So what are the differences between a DFA and an NFA? So firstly, we remember that DFA was denoted by a 5-tuple Q, sigma, Q0, F and delta. NFA is also denoted by the same 5-tuple. Now, what was Q? The Q was a finite non-empty set of states. In case of NFA also, it is same finite non-empty set of states. There is no difference. Sigma, it's a finite non-empty set of input alphabet. In case of NFA also, it is same. Q0 was the initial state in case of a DFA. In case of NFA also, it's the same. Set of final states was given by F. In case of NFA also, the set of final states is given by F. So up to this, there is no difference between a DFA and an NFA. So where is the difference? The difference lies in the transition function. If you remember the transition function delta for a DFA, okay, so given a current state and an input symbol, it took us to one of the states in the set Q. So basically the transition function was a mapping from the Cartesian product of Q and sigma to Q. So for a given state and a given input symbol, the machine would go to one of the states in this set. Now what about NFA? In case of NFA, the transition function is a mapping from the Cartesian product of Q and sigma to the power set of Q. Now why is that? Because, you know, when you are given a current state, an input symbol, there are many choices. The machine may not go to any state, which is like the empty state. It can go to one of the states. It can go to two states in the set. It can go to multiple states. It can take as many choices. So it's like the set of all subsets of Q, which is the power set. So the transition function is different for DFA and NFA. Everything else is same. Another very important point that we should understand is that if a DFA can be designed to accept a regular language L, then an NFA can also be designed to accept the same regular language. Conversely, if an NFA can be designed to accept a regular language, then it can be converted to a DFA which will also accept the same regular language. Now, which essentially means is that both DFA and NFA has equal power. Okay, if you can design a DFA for a regular language, you can also design an NFA to accept the same regular language, and vice versa. If you can design an NFA, you can convert it to a DFA. So sometimes in the exam, they ask you which is the more powerful machine, DFA or NFA. The answer would be they have equal power, because for a given regular language, if we can create a DFA which can accept it, we can also create an NFA to accept it. Or conversely, if we can create an NFA which accepts regular language, we can convert it to the equivalent DFA which accepts the same regular language. Okay. Finally, let me talk about how to understand which strings in a language are accepted by an NFA. In case of DFA, it is pretty simple. For example, if I ask you, is string 0 accepted by this DFA? What you could see is from the initial state for that string, is there a path to the final state? So given initial state A and input 0, the string goes to state B, which is final state. So you would say yes, input 0 is accepted by this DFA. Now if I ask you, is input 0 accepted by this NFA? Now the answer is not that simple, right? So from the initial state A, on input 0, you can either go to state B or you can go to state C. Now if you go to state B, it's a final state, so that string will be accepted. But if you go to state C, it's not a final state, so that will not be accepted. Input 0 will not be accepted. So how do we determine whether a given string is accepted by a NFA or not? The answer is that if for a given string S, there exists at least one path from the initial state to a final state in an NFA, then the NFA is said to accept the string S. For example, for input string 0, is there a path, at least one path, which takes the NFA to a final state? Now from A, if you provide input string 0 and take this path, it goes to a non-final state. But from A, if you provide input string 0, it goes to a final state B. So there is at least one path from the initial state to the final state for this input string, and hence the NFA is said to accept this string. Okay, so this is how we determine the language accepted by an NFA. So in this class, we had a brief discussion on NFAs, and we understood what is a non-deterministic finite automata, what is the non-determinism in its behavior. In the next class, we'll look at some problems on NFA. Thank you.